Hi all, I'm Paul Vogtländer from Google Research, and I'm presenting Connecting Vision and Language with Video Localized Narratives. Here we want to annotate complex videos like this one. For this, we want to create multimodal video descriptions that are localized in space-time, and we want to capture the story of the video. We annotated 50,000 videos of the datasets OVIS, UVO, OOPS, and kinetics. On top of this, we defined two tasks, namely video narrative grounding and video question answering. On the right, you see an example of our annotations. For each actor separately, we have a text description, and almost each word is localized in space-time. For example, the word ostrich is shown in dark red, and here you can see that it is localized on different keyframes. The main idea of the annotation process is that an annotator will talk to describe the video while at the same time moving their mouse pointer over keyframes. Here the speech and the mouse pointer are synchronized, which allows us to localize each word with a mouse trace segment in space-time. In detail, the annotation process works as follows. First, the annotator watches the video and makes sure they understand it. Afterwards, they select the important actors of the video, and for each actor, select a few keyframes. Then for each actor separately, they will speak to describe the name of the actor, its attributes, and the action it performs on other actors like the ostrich and also on passive objects like the cup. And during speaking, they will move their mouse pointer to localize each word in space-time. Lastly, the annotator will provide a manual transcription of their own speech for a flawless caption. The use of keyframes here avoids a race against time, which would occur when attempting to draw directly on the video while it's playing. Our annotation protocol focuses on the story of the video from the viewpoint of each actor separately. This disentanglement between actors allows us to even capture very complex events. Let's look at some statistics about our annotations. In total, we annotated 50,000 videos of 4 datasets with 3.5 million words. The datasets considered are OVIS, UVO, OOPS, and kinetics. A detailed analysis shows that our captions are long, with 75 words per narrative on average. A manual evaluation shows that we have 97% semantic accuracy of our captions. And depending on the setting, the mouse trace precision is between 73% and 93%. Compared to the most relevant previous dataset, ActivityNet, our captions are significantly longer and cover more nouns, verbs, adjectives, and adpositions. Now let's have a look at an example annotation video. An ostrich is looking at the piece of food held by the man and suddenly grabs the cup of food and starts eating. On top of these annotations, we define two new tasks. The first one is video narrative grounding VNG. Here the task is to localize each noun with a segmentation mask in each frame. A key challenge is that multiple identical nouns need to be disambiguated using the context provided by other words. The input to the VNG method is the raw video, together with a caption seen below. And for the caption, the position of certain nouns is given, like parrot and other parrot, and then they need to be localized on a pixel level. For example, this first parrot is shown in blue, and in the output, it will be marked by a blue segmentation mask. Both instances of parrot here need to be disambiguated based on the context of the language, in particular the red-black neckline. We define our new video narrative grounding benchmark on the two datasets OVIS and UVO, and our annotations cover a total of 8,000 videos with 45,000 nouns of the captions. To create the benchmark, we connected the nouns to existing segmentation masks for these datasets, and we also added additional masks. The most related previous task is referring expression video object segmentation. However, in this task, one sentence refers to exactly one object, while video narrative grounding is more challenging. Here we need to localize multiple nouns and we need to disambiguate them using the context provided by other words. Additionally, our annotations cover 2 times the number of videos and 3 times the number of objects than the biggest referring expression video object segmentation dataset. We created a baseline method with format VNG and achieved an accuracy of 32.7% on OVIS and 46.4% on UVO. The second benchmark we define is video question answering. Here, we create questions and answer pairs automatically from the narratives, and afterwards have them verified by annotators. We consider 2 types of questions. The first type are text output questions, for which we annotated 44,000 questions on 9,500 videos. An example question answer pair is, what is the shape of the girl's head? And as you can see in the frame on the right, the correct answer is cone. We conducted a baseline experiment using Pali and achieved an accuracy of 49%. The second type of questions are location output questions, for which we have 18,000 questions and answer pairs and 9,800 videos. We validated the ground truths given by mouse traces and found that they have a high accuracy of 93% in this benchmark. An example question for this task is, where is the girl that is wearing a pink dress? The ground truth here is given by a mouse trace, and the method has to predict the bounding box. We conducted a baseline experiment using Referforma and achieved an accuracy of 48.3%. In conclusion, we introduced a new annotation protocol, video localized narratives, and used it to annotate 50,000 videos of 4 datasets. Furthermore, we introduced new benchmarks for video narrative grounding and video question answering derived from these annotations. Please visit our project page to download our new annotations. Thank you for your attention.